Hello, my name is Roger Singleton. I own a company called Silt Saver in Conyers, Georgia. I've been in the construction industry about 40 years, building homes and developing residential subdivisions. In 1999, the NPDES program came to Atlanta, changed my way of doing business and my bottom line. I couldn't meet the federal guidelines with the products that Georgia allowed me to use. I found that the statewide QPL maintained by the DOT was a product of evolution, a listing of materials of various sieves and flow rates, none of which had been tested to meet the federal guidelines of 75% efficiency. I also found that the M288 material standard relied upon across the country for silt fence specification was taken from paving underlayment, a material specifications never tested under slurry conditions or as a complete silt fence system. A material specification needed to prevent potholes under pavement does little to help us with our water quality. With this said, we set out on our own. In 1999, our company was started to develop products designed for specific purposes for sediment control that can be compared by performance and results. Today I want to talk about silt fence and the need for specification on plans. Silt fence is designed for temporary but a significant job where speculation of performance should not be left to chance. Silt fence is designed for control of sediment movement displaced by sheet flow or overland flow. A silt fence system is composed of various components, fabric, post, and method of attachment, each component relying upon the other. I have questions as to why are test results only available for fabric specifications? Why is it not tested as a system? Let me demonstrate some of the differences of silt fence and explain the need for product specifications by name on your plans. We're going to start with the fabrics. We've been out to a lot of job sites, and on these job sites we typically find this type silt fence. This is about $15 for a 100-foot roll. It's the cheapest thing on the market, and we put it up for our last line of defense on our job sites, and we expect it to give us the filtration. This does not meet the federal guidelines of efficiency. A lot of job sites also, you'll see the monofilament silt fence, which Georgia requires next to every stream. It's a middle-of-the-line product. It's typically attached to support, which is wire and steel post. Very costly apparatus, delivers minimum. Over the years, our silt fence that we used in Georgia, attached to wire, tend to fall off the post when the hog rings tore out. You get a pressure point, the polypropylene would decay, the hog rings would tear out, and you go down the road, you see a lot of fabric on the ground, the support system still standing. What we tried to do with our silt fence is start from scratch. This is a spun-bond polyester fabric, has a very high flow rate, has a very good trapping rate. And we actually had them incorporate a scrim inside the fabric. I don't know whether you can see it on the camera or not, but it actually has a net inside the fabric, and we have actually combined the support system within the fabric itself. We put this fence on a wood post system. It's a system that's been tested by the University of Georgia. It has an 1¼ by 1¾ hardwood post, and the fabric is sandwiched to these posts with a bonding strip that's 1 inch wide by 24 inches long, and it sandwiches the fabric in, and it doesn't let you have any horizontal movement, so the system itself actually gains its strength off of all the posts rather than off hog rings or one post. But again, we've incorporated the support system in the fabric. Now today we want to show you part of the lab test that was done by the University of Georgia. They tested these fabrics there under the ASTM test method. They tested it under this quick test method. They actually raised the table to an 8% grade to test it on like a 2-to-1 slope. and they tested my fabric and the monofilament fabric that Georgia typically uses side by side under various slurry conditions and various flow rates. But we want to show you our test and give you some kind of sampling of how the products work in the field. First of all, we want to show you the dirt that we use for this testing, which is a Georgia red clay. We've taken it, we've sifted it, we've tried to make it equal, and we use a level teaspoon when we get to this point of this dirt to mix up our slurry conditions. We're going to go over here to the test apparatus first, and we're going to show you the fabrics. This is the belted silt retention fence from Silt Saver. This is the monofilament silt fence. It is the middle of the line, and this is typically what you find on your job sites because there's no specification on the bid, and typically the cheapest product gets the job. So we're going to show you flow rate first. Now, the combined amount of water in one pitcher and one washout bottle is equal to these lines on the bottom of these pots. So as we do the demonstration, you'll be able to watch flow and efficiency. So first of all, we're going to start with a clean water test. Let me cut these valves off. We're going to pour in the clean water. And we're going to show you clean water flow on these fabrics. Now, we talk about silt fence having flow and efficiency. Typically, silt fence will flow clean water, but once you get slurry behind it, it creates a secondary filter to the back of the fabric and actually slows this water down to a seep. You have very little flow coming through the fabric. First of all, we're going to do the flow rate. This fabric has about 160 gallons a minute flow rate. This fabric's on the DOT list in Georgia, and it actually is called for 70 gallons a minute. I'm not sure what the manufacturer's suggested flow of this fabric is, but as you can see, as the pressure comes behind those woven strands of flat strands, it gets tight and it doesn't let clean water come through it. We're going to open up this fabric and go ahead and let this water out. I think you can see that you're not getting any flow rate there at all. And when you have the impoundment of water or mud behind the fabric, it leans more strength to the point that you've got to have a structural system that holds up under those conditions. But in order to expedite the test, we're going to go ahead and let this water out and move on. All right, again, we're going to come back over here to the dirt. And as I said, we're using Georgia red clay. Clay is probably the worst case scenario for what we're doing. And we'll be adding 1 level tablespoon to each one of these containers. Alright, now we've closed the valves. We're going to add the dirty water to the pots. Alright, Alright, now we're back to start over again. Now you've got the dirty water in there. This is actually a slurry test. Why don't you look around the room and raise your hand and see how many people in this room has actually seen a slurry test. What we find out that very few people has ever seen how a silt fence reacts under dirty water testing. But anyway, we're going to open the valves. We're going to show you a difference in flow rate. We're going to show you efficiency. Then we're going to take a sample of the water that actually comes through the fence after the first flush, and we're going to test it on an NTU meter. That's the belted silt retention fence. That's your monofilament fence. That's your flat film that you normally see on your job sites. And we're going to add the water that we had left over, so we'll have equal contents. You can watch the line at the bottom of the pot. We're going to come back and try and take samples on this one right here. Most times we can't get a sample because it don't flow. As I said, your silt fence gets down to a seep. You've got a secondary filter on the back side of the fabric that controls the flow. Got two samples right there to look at. We're going to move over here to the NTU meter. This is the sample for the one in the middle. Take a reading on that one. Looks like 781. We'll put the one for the belted silt retention fence in. We'll read it. 60.9. We now have the sample coming out of the flat film on the end. $580. There's your three samplings of three different kinds of silt fence. You get what you pay for. Not a lot of difference in money here when you talk about the liability of a total job, but it does show the need for specifications on your plans. Some of the things I want you to think about before we leave you is before you send out another unspecified erosion and sediment control plan, ask yourself these questions. Who is the responsible party, the primary permittee? Who has the liability of the failure? If a product is not specified on the plans, who will make the decision for you? If a product is not specified, how does the contractor know what to bid and what he'll put on his job or your job? And does the bid mean cheapest product? Does the cheapest bid mean cheapest product? We're asking you to compare performance, then price. Silt fence is your last line of defense. It's not worth the gamble. Please specify Silt Saver belted silt retention fence on your next plan. It is your last line of defense. Thank you, and I hope you found it interesting.